You need to select an algorithm. An algorithm, right, will teach machine how to digest input and output and learn the pattern between the two. And it will give you a program. So a model actually is a programmer. This model represents machine intelligence. Okay? But if you say there are noise in the data set, you do not clean, then the model that you can train will be a bad model. It cannot give you correct prediction. So later we will do very simple stream processing or text cleaning. Some of the steps that we will consider, right, include spanning, lowercase conversion, tokenization, and stopwatch removal. Yeah. So we'll be using this NLTK library. It is already available. You can open Anaconda Prompt. Anaconda Prompt. Just type here Anaconda Prompt and open it. You can just do a quick check. For example, Conda list NLTK and press enter. If let's say any library is available, already installed, you can find. You can see the name, you can see the version. Let's say we try another one. Conda list text block. We have not installed text block yet. So by right, when you check it right, you cannot find it. But once you have installed it right, you should be able to see the name and version. Okay? So NLTK is already installed, you'll be using NLTK. Right? Okay, we run this step, import NLTK. Okay, we need to uncomment this. Okay, sorry, comment this. Run it. Okay, import NLTK. Next, we will be using this sentence to do pre-processing. This is a very simple text that consists of 3 sentences. Okay. So, first thing first, we want to remove punctuation. So, how does punctuation look like? If you remove this sentence, we have a few punctuation here. Parentheses, we have period, we have question mark, we have exclamation mark. All this you want to remove. Okay. You can either create your own punctuation characters, or you can find from the string module. So import string module, there are a lot of things that you can access, including ASCII letters, uppercase letters, lowercase letters. But we actually would like to access something else, not all these things. You can access punctuation. So we don't want to process all these in the text, we have to remove them. So next step, we create a pattern using regular expression. Then this is a text. We look for a match for this pattern in the text. If there's a match, we replace it with empty string. This is how we remove all the punctuation. That's why we learn this in Big 3. Okay. So now, after we run this right, we have really successfully removed all the special characters. Yeah. Next, we want to remove numbers. So why we want to remove numbers? Can we keep numbers? We actually can keep numbers, but if you keep numbers, right, you will make the processing part more complex. For example, if we have another sentence, 3 tomatoes, another one, 4 tomatoes, 5 tomatoes, 1,000 tomatoes, 1 million tomatoes. There will be so many different versions though. We don't want to increase the complexity by including the numbers. So by removing all these numbers, right, even though the text that contain numbers, right, may not be the same, but actually make the processing part a lot simpler. So now we remove numbers. And this machine understands it is about buying tomatoes, it is about buying vegetables and cucumbers, even though we remove the numbers. Even though we know that 1,000 tomatoes is different from 500 tomatoes. Okay? Okay, next. We will skip this. Okay, we move on to the next part. Okay, before that, I just want to highlight one thing. If you notice, just now when we did this punctuation removal, we apply the code here onto original text. We get clean text. This clean text is the output from this step. It will be used as an input in the next step. Clean text is an input in the next step. Then we further remove numbers. When we get another clean text right, without punctuation, without numbers, we use it as an input in another step here. Okay? So the third step is about converting all uppercase letters to lowercase letters. So why we want to convert all the uppercase letters to lowercase letters? For example, vegetarian restaurant. We have capital V and R, right? We want to do lowercase conversion. Any idea why? Correct, you're right. machine cannot understand words or sentences. So machine will think that this vegetarian and this vegetarian, they are two different things. So we don't want to create complexity, increase complexity, but actually they refer to the same thing. So by changing this capital V to this V, they actually become the same thing. Okay? So this is why we want to do lowercase conversion. Okay, but when you do lowercase conversion, you will be extra careful. For example, if you have this example here, s dot h dot e dot ssg. If you follow the first step, we remove punctuation, what happens? We will have this. If you further remove number, no number, right? Okay, then we do lowercase conversion, we will get this. So we accidentally change the meaning to something else. We don't want this to happen now. Okay? So when you want to do pre-processing, you be extra careful. So it also means that lowercase conversion, maybe it's a must, but you have to do it carefully. Next, word tokenization. Word tokenization is the process of splitting a string or piece of text into smaller units. For example, you split it into maybe words, phrases, or sentences. Okay, now we apply this onto our original text first. Later, then we apply it onto clean text. Then we compare them. Okay, first, this is a sentence. We can do tokenization using whatever we learned in the past. For example, split function, split by white space. But this is not a good approach because you can see that if it's split by white space, right, this is considered one token. But this is not a number, this is not a word, it is meaningless. Okay? 2 is a number, but this is not a number. So if you use split, right, this is not good. This you can try at home. If you run it now, it doesn't work. Because we need to download NLTK data, which includes some other packages. So we cannot use it now. We skip this one and we move on. This will work. But if you do it using reject key, right, tokenize, you need to write your own pattern. And you can see that when you write your own pattern, right, when you change the pattern, you will have different output. So whether you use splitter, you use this or this one, you have 3 different outputs already. We just want to split it into smaller tokens, but we get 3 different sets of answers. We try 2 more, we get another set and another set. By right, we should get the same set. So it means that when you apply all these functions, right, onto our original text, this is what you get. Different answer that use different methods. But if we apply it onto clean text, after we have removed all the punctuation, numbers, and we do lowercase conversion, right, if you use split, this is what you get. If you try the other method, for example, remove this, it doesn't work. You get the same output. You try another method, you get the same output. You try another method, you get the same output. So if you do this in the right step, you start with punctuation removal, number removal, lowercase conversion, then when you do tokenization, you will make your process even more consistent. Regardless of whether you try approach A, method A, B, or C or D. Yeah. Sentence tokenization, I will skip this. Okay, next. Stop words removal. What are stop words? If you refer to the picture here, right, it says stop words are words that have very little semantic value. For example, in this sentence, some is a stop word. From is a stop word. The is a stop word. Any word, right, that is widely used in many different sentences, they are stop words because they do not contribute a lot meaning to the sentence, but little bit only. So by removing stop words, we can again reduce the complexity of processing a text. Okay? So if you run the code here, you can see all of the possible languages that you can have access to, they are stop words, but we cannot do it now. Okay? Because we need to download the package. Okay, we skip this side. So later you can try this at home. This one also doesn't work, you skip this. Next, stemming. Okay. Stemming and lemmatization, they are 2 different processes, but we apply them because we want to achieve the same objective. We want to reduce the complexity by changing similar terms to their base form. For example, run, runs, running, ran. Actually, they carry almost the same meaning. We don't want machine to think that run, runs, running, run, ran. They are all 4 different terms. They actually carry very similar meaning. So if you do stemming or lemmatization, you convert them back to their original form, which is run. So instead of asking the machine to remember 4 different terms, you can ask the machine to remember only one term, branch. So there are 2 different ways to do it, stemming and lemmatization. This is a very complex process. This is easier. Stemming involves the use of human-created rules to do the cutting of certain letters out. For example, we have 5 words here, right? By doing stemming, right, it means that we apply human-created rules to cut maybe 1 or 2 or 3 letters out, so that it can be written back with basic form or base form. But you can see that when we apply stemming, right, there's a risk here. We may end up changing words into meaningless words. When you do lemmatization, this will not happen. This will never happen when you do lemmatization. But this is a very complex process, and most probably when you apply lemmatization, right, you will see very minimal change. For example, change is still change. Changing is still changing. Changes could be changed. Change could be changed, but changes still changes. So you want to change everything to one word, right? You can apply stemming, but there's a risk here. When you want to use lemmatization, you will see minimal changes. Okay, you try, for example, Lancaster stemmer. You can see that we have 6 or 7 different words, right? They are all changed to connect. This is what we want. But when you try with the use of drivers and other words, similar words, we get meaningless terms. Okay? But this will not always happen to all stemmers. When you try portal stemmer, it works. When you try snowball stemmer, it also works. But of course, this is only 2 examples. If you try any other example, it is possible that Lancaster stemmer can do better than snowball stemmer. You have to do an experiment. Yeah. So next we have this lemmatization. Lemmatization also doesn't work. You need to complete the download first. But if later when you try this at home, right, you will see that for this example here, most probably many of them remain the same. With only 1 or 2 change, but majority remain the same. Okay, so probably you can see that when you use lemmatization, you cannot expect to see many changes, and when you use stemming, you can expect to see word change to something that is not meaningful. Okay, sort of quick stemming, we cannot do this. Again, we need to complete the download, so I will skip this. This is simply the step of assigning a role to different words in a sentence. For example, book. Is book a noun or a verb? So if let's say we do not know whether this is a noun or verb, right, then there are many possible meanings we can consider. But if we assign a role to this verb or word, we know that this is noun, right, then we will not consider any other meanings that are all under verb. Okay, so we will skip this. You can run it later at home. Chunking, run this, skip this as well. Okay, next part. NumPy. Okay, if you remember last time when we learned connection, we mentioned that Python doesn't have built-in array. But because array is very useful, we are so comfortable using array when we learn other languages. So there are people who created a library that allows us to use array in Python. So in order to use Python, array, you need to import NumPy. Okay, we can create array. You can check a type. So this is a type of array, NumPy.md array, multi-dimensional array. It can be 1D, 2D, 3D, and many D. And shape is very useful. Okay, shape will tell you how an array looks like. So this is 1D array. Every time when you are doing a 1D array, right, you see only one number. But for 2D arrays, later you will see 2 numbers. You can also create a number, an array with the use of random function. Okay, now we have 2D array. Just provide 2 numbers. The first one is meant for row, second one is meant for column. Yeah. Again, if you are accessing a huge array with many rows and columns, you cannot do the counting, but access shape. Then you will know how many rows and how many columns the array has. Plotting we will skip because we will do this in the near future. Plotting. Okay. Okay, then basic pandas functionality. We don't want to deal with array so much because if you look at array, all are numbers. It's difficult to visualize it. Look at 2D array. Better, but still difficult to visualize it. We want to present it in a different format, which is data frame. Look at data frame. Data frame actually is similar to array, but only 2D array. Just that it has labels for columns. It has labels for rows. That's it. So it means that you have array come with labels for columns and rows, and that is data frame. Okay. So this is 2D array we created just now. we actually can create a data frame from 2D arrays. Okay, for this purpose, okay. Create a 2D data frame from 2D array. So you can see that because we have 2D array, we don't have labels. So index values are used as the default value for labels. Okay, so we can check the shape, 6 rows, 4 columns. You can access the column labels. You can access the row labels. You can even change the label value. For example, we change 0, 1, 3 to ABCD. We change 0 to 5 to some other names. Okay, you can see that this is how we create a data frame from 2D array, and we change the labels afterwards, right? We actually can put all these 3 steps into one step. Scroll up, look for this. The step that we use to create data frame. Copy this one. Copy this step, okay, and then create a new code cell. Put it here. Then scroll up and look for this one. Columns equal to A, B, C, D. Instead of putting this thing into 3 different steps, right, we can combine them into one step. Then next, copy this one. Index equal to rectangle, or rect 1, rect 2, rect 3, until rect 6. Then you click run. Okay. Yeah, so either you create this in one step or you create it in 3 steps. Okay, next, we want simple exercise here. Write Python code that prints the total number of rows. So if you remember, we actually can access the shape of data frame, df or shape, right? When you print df or shape, what do you see? You see a tuple, right? And we learn that we can unpack a tuple. So if you can do this step, for example, row, comma, column equal to df or shape. It means that you unpack the value into 2 different variables. Then you can print the number of rows and columns. It is important for you to know how to access the size in terms of row or column for a data frame. Because, for example, this one, if you open this cookie reviews, there are several thousands of rows. So you don't want to do the counting. Just import it into the data frame format. Then you can check the shape using this shape property. Yeah? So next step, we read this CSV file, we read the content into data frame. And this is how it looks like. So is it easy to read when you have labels? User ID, staff, review. Yeah. Head function allows you to see the first 5 records. Tail function allows you to see the last 5 records. You can really control how many records you want to see, 10 or 20 or 30 or 40. It is important for us to go through some samples. You cannot just assume that, okay, I want to process this, just read in and pre-process, remove punctuation and this and that. Sometimes you want to go through a few examples to understand the data. Okay? So you can actually use some of the functions like, for example, head or tail to read some samples. Okay, next. We learned this already, columns of value. This is allow us to print the columns label, right? Okay, what if you want to print the entire column? df is the name of the data frame, dot the label of column. This will give us access to the entire column. So either you do this way or you do this way. df brackets the label of column. The two are equivalent, but we use 2 different labels here. Okay? Okay, next. I will just skip this. Okay. Next we come to ILOC and LOC. ILOC and LOC, these two are very useful functions, but they might be confusing. ILOC, you have one additional letter here, I. I stands for integer. So you look for certain thing in data frame based on integer to identify their location. So it means that you'll be using integer, right, to do indexing. Okay, we look at 2 examples here. For example, we have created the data frame which is df, right? If you want to access the first row, we use index value 0. Okay? And we learned that 0 is for the first row, 1 is for the second row, and so on, right? And minus 1 is for the last row. So you can use minus 1 to indicate the last row. This is how we do indexing. How about column? See, 0 is for the first column, 1 is for the second column, -1 is for the last column. But you need to indicate where this is for column. So you need to use the comma here. Any value before comma is meant for row. Any value after comma is meant for column. So all rows and one column, the first column. So you print the first column, but all rows. Then this is the last column and all rows. If you put here 0 and 1, it means the first row and the second column. So they intersect and they give you only one value, which is 5. Okay? Since you can have one row intersect with one column, you can have multiple rows intersect with multiple columns, right? So 0, 1, 2, 3, multiple rows. 0, 1, 2, which is 2 columns, multiple columns. Then you will get a mini data frame. So 1 intersect with 1 or multiple intersect with multiple. Yeah. Because there are times if you want to cut the portion off from the data frame to understand it, so you can use ILC or LOC. What about LOC? LOC solely relies on the use of label. No more indexing, label. Okay. What is the label for the first row? 0. This 0 is not referring to indexing, it is the index value for the first row. And it is also the label for the first row. Okay? But if you want to access the last row, you can no longer use -1 because now you're not doing indexing. You need to provide the label of the last row, which is 9, 1, 2. So, can you see the difference? Here you can use -1 indexing. Here you cannot use -1. You must use the label. Then for column, it's easier to understand now. This is the label for column, label for column, and label for column. Okay. So later you can compare the two. Now we move on to this one. You can try this later. We move on to the more important part first. Text similarity. Okay. Text block is not installed yet. You can install it by running the code here. Pip install text block. Okay. So this one is an alternative of NLTK. You can do tokenization, spelling checking, policy tagging using either text block or NLTK. So we are not going to run this because we are going to stick with NLTK here, but this is another option. So we will skip this, we go to the last part. Okay, this is very important because we will be dealing with text in the near future. So first, you need to understand how to use comma vectorizer. Okay, suppose we have one paragraph here. Okay, we have another paragraph